This is the notes page for combining functions symbolically and graphically, but mostly symbolically. We're going to do addition and subtraction, and then we're going to do multiplication. So the notation is like this. The sum of the function f plus g is defined as, if you see parentheses f plus g of x, that simply means f of x plus g of x. And if you see f minus g of x, that simply means the function f of x minus the function g of x. So the way you find the domain is straightforward as compared to others. You find the domain of f, and then you find the domain of g, and then you take the intersection. So that's the symbol for intersection. So what that means is you find a number line. You find the domain of f, draw a number line. You find the domain of g and find the number line, and then you find the intersection. So we'll do that. And so the first example, f of x equals 2x plus 3, that just has a domain of all real numbers, because this, we should know, is just a line. When x is any number, y is any number. So you can put anything in for x and get an answer. So that means all the x's in the universe will make a y value. So the domain is all real numbers. Now g is just defined by the table, and so its domain is just the numbers. So we'll have set notation -2, 0, 1, 3, and 5, and that's it. Those are the only numbers that give you a y value. So the intersection of those two, if you imagine a number line here of everything, but a number line here of just -2, 0, 1, 3, and 5, then the intersection is just this. So the domain of f plus g is the intersection is just this. So you really didn't have to do a number line for this, because you can tell that the intersection is always going to be the smaller of the two, in this case, just those 5 numbers. Okay, so example 2 will go symbolic. So f of x is equal to x squared plus 1, and g of x is the square root of x minus 2. We need to find the domain of f plus g and f minus g. Well, the rule is the same whether you're finding f plus g and f minus g. So the domain of f is, this function is a parabola that opens up and is shifted up by 1, and it doesn't matter what you put in for x. You can put negative numbers in, square roots in, positive numbers. So the domain for this function is all real numbers, because there's no restriction on what you can put in for x. However, g of x has a restriction because it's under an even index radical. So we know that what's under the radical has to be greater than or equal to 0. So we know that the only numbers that you can put in for g here would be the numbers that are greater than or equal to 2. So the domain of g is bracket 2 to infinity. Okay, so we want to find the intersection. Well, we know that this is everything, and this is just 2 to infinity. So this is going to be the domain of the sum and difference. But just to make sure you understand, the domain of f, the number line is this, and the domain of g, the number line is from 2 to infinity. So this is the graph of the domain of f, this is the graph of the domain of g, and the intersection is only where they overlap. So the intersection is just 2 to infinity, like we said. All right, now this one, I am going to compute f plus g. I'm not going to do that. But to compute f plus g, you add those two functions together. So f plus g of x is equal to the function f, x squared plus 1, plus the function g, which is square root of x minus 2. And then you want to look and say, are there any like terms? And like terms, you can't add this x squared and this x, as this x is stuck with the minus 2, and it's under a radical, so that's it. Can't do anything. And so f minus g of x is equal to x squared plus 1 minus the square root of x minus 2. Now here's a common mistake, so I'll just do it and then erase it, is some people are not comfortable with this because they don't understand what this means. This means to compute doesn't mean to give me a number answer. It means to create a new function. I don't have a number going into these functions, so I'm going to just create a new function. But what people do is they're not comfortable with that, so they'll just set it equal to 0 for some reason and try to solve for x and give me an answer like x equals whatever. But you've got to be comfortable with the understanding that sometimes when we're adding and subtracting functions, we're just creating new functions. So don't overdo it. You're done there. Okay, so example 2, I did put a graph in here. You're given a function, f of x equals negative 1/4 x plus 1, which is a line. So I wanted to show you what that looks like. The y-intercept is 1, and the slope is negative 1 over 4, down 1 over 4, down 1 over 4, and that's that line. And it goes on forever and ever. So you can see the domain. All the x's are allowed to be put in there. The domain is all real numbers. And then the other function is 1/2 x minus 1. So the y-intercept is negative 1. And then slope is 1/2 up 1 over 2. And that's that line. And that domain is all real numbers. Okay, so the domain of f plus g is going to be all real numbers because the intersection of all real numbers and all real numbers is all real numbers. So this next one is f plus g of negative 4. So notice the difference between this example and that example. This time I'm giving you an x value. So if you're asked to find f plus g with nothing, it's understood that it's just f plus g of x, and then you would just create new function. But this time I'm saying f plus g of negative 4, which is actually easier and kind of more fun to do. And I would do it this way. Instead of adding first, I would remember that f plus g of negative 4 means f of negative 4 plus g of negative 4. Which means I would find f of negative 4 first and g of negative 4 and then add. I think that's easier. So I'm going to put negative 4 into f. So f of negative 4 is negative 1/4 times negative 4 plus 1, which is negative 1/4 times negative 4. Those are reciprocals. That's just going to end up being positive 1, and 1 plus 1 is 2. And then g of negative 4, I'm going to put negative 4 in for 1/2. And some of us are better with fractions than others. So you can put that in your calculator, or you can remember that anything can be made a fraction. And this 2 goes into this 4. So 2 goes into 2 once, and 2 goes into negative 4 negative 2 times. So that means 1 times negative 2. That's negative 2 minus 1. Signs are the same. Negative 2 and negative 1 add up to be negative 3. You can use your calculator. All right, but then remember we're adding those together. So the final thing, f plus g of negative 4 is 2 plus a negative 3, which is negative 1. Okay, so see, when you get a number, you just have to compute that. But this time it says find f plus g of x, which means you're creating a new function by adding f of x plus g of x. And so since you have no number to put in there, you're going to add the two functions together. So that's f of x plus, and then notice how I use parentheses every time. We'll talk about this all semester because you never know when there's a negative out here that needs to be distributed. So once I write with my parentheses, then I look, do I have like terms? And I have an x term here, negative 1/4, and an x term there, 1/2. So I'm going to add negative 1/4 plus 1/2. And I would use my calculator if I were you. Or you can get a common denominator. When you're adding, you need a common denominator. So negative 1/4 plus 1/2. Your calculator will give you the decimal. If you hit the squiggle right here, it'll change that to positive 1/4. Okay, so negative 1/4 x plus 1/2 x. The algebra says add like terms. Use the calculator to do the arithmetic. That gives me 1/4 x. And then 1 minus 1 gives me 0. So this is a new function. And this is why I have the graph, because I want to show you what you're going to get. You're getting a new function. When you add this line plus this line, you get this line. It has a y-intercept of 0 and a slope of 1/4, up 1 over 4. And that is the new line. This is the line f plus g of x. We created a new line. So get comfortable with just creating a new function. Don't try to set it equal to 0 and give me x equals, because that's not understanding the concept. All right, so let's do this again. You might want to pause and try both of these. I'm going to go ahead and do it. So f minus g of 3 means I can find f of 3 and then find g of 3 and then subtract them. So f of 3 is negative 1/4 times 3 plus 1. I'm going to use my calculator this time. So that's negative 1/4. And I just like to use parentheses. And if you haven't caught it yet, that division is how you get the fraction in there. Times 3 plus 1. And I'm going to get a decimal. I'm going to use the squiggle and get 1/4. So this is 1/4. And then g of 3 means 1/2 times 3 minus 1. Use your calculator. You'll get 3/2 minus 1. I'll go ahead and use my calculator here. 1/2 times 3 minus 1. So you can use the calculator to do the arithmetic. Get 1/2. And then you're going to subtract those two. And again, you can use a calculator or you can use common denominators. But you're going to get negative 1/4. And that's what the value of f minus g of 3 is. Now, since I gave you a number, you end up with a number. But this one, I'm not giving you a number. So this means you're creating a new fraction. And if you paused it, ask check to see if you did this. This minus is going to be tricky. This means f of x minus g of x. And f of x is negative 1/4 x plus 1 minus parentheses g of x, which is 1/4 x minus 1. Now see, this is where the parentheses comes in handy. So many people miss this. You have to distribute this negative. So before I combine like terms, I'm going to distribute that negative. Most people remember to distribute it to the negative 1/2 x because it's in front. But did you remember to distribute it to the minus 1? That's plus 1. So then negative 1/4 x minus 1/2 is negative 1/4 minus 2/4, which is negative 3/4 if you did it in your head. Negative 3/4 x, and then this time 1 plus 1 is plus 2. So if we subtract those two functions, we're going to get a new function like this. And I'll graph it. So the y-intercept is 2. I'm going to graph 2. And the slope is negative 3 over 4. Rise over run. That means down 3, right 4. So down 1, 2, 3, right 4. 1, 2, 3, 4. So this is what the subtraction of these two functions will give me. Okay, let's see what else we got. So here's another graph. What happens when you add a parabola to a line? All right, we're going to do symbolically. First of all, the domain of f plus g. Well, if you look at the equations, we only know there's a few restrictions. There's not many. You can put anything in and square it and add 1. So this domain is all real numbers. The graph shows you that. You can put anything in for x and you'll get a y. This is all real numbers, so this is easy. The domain of f plus g is all real numbers. Okay, f plus g of negative 3 means to find f of negative 3, which is negative 3 squared plus 1 always becomes positive. Let me just really quickly show you common error. If you put it in like this, you're going to get the wrong answer, because the calculator understands order of operations, and when you put it in like this without parentheses, it's going to give you, it's going to square the positive 3, 9, and then make it negative 9. And a negative squared is never negative, so you have to understand more than the calculator. Actually, the calculator's right. It understands order of operations. This is what you mean. This is what you need to put in. I don't do that, though. I know that a negative 3 squared is the same as a positive 3 squared. So just to save myself keystrokes, I put that in. I just do a little mental math. A negative 3 squared is going to be the same as a positive 3 squared. But don't do this. Anyway, so this is going to give me 10. And then g of negative 3 is going to give me negative 3 minus 4, which is a negative 7. And then we're supposed to add those together and get 3. So the evaluation of f plus g of negative 3 gives me 3. This one I can't evaluate because I'm not given a number. I just have to add the two functions together. So that's going to be x squared plus 1 plus x minus 4. And then I don't have anything to distribute, so the parentheses are not needed. So I'm just going to add like terms. X squared doesn't have a like term with anybody over there. You have to have the same power. X doesn't have a like term with anybody. And then 1 plus a negative 4 is negative 3. And I put my answer in descending order with the exponent, largest exponent first, and then the next term with an exponent of 1. That's your final answer. Don't try to set it equal to 0 and solve. You're not. You're trying to find a new function. All right, if we do f minus g, the domain is the same. F minus g of negative 5, you might want to try these next two. Pause the video, try it, see if you get the right answer. All right, I'm going to go ahead and try it. So f of negative 5 would be negative 5 quantity squared plus 1, which is positive 25 plus 1, which is 26. F of, g of negative 5 is negative 5 minus 4, which is a negative 9. Okay, now f minus g of negative 5 means f of negative 5 minus g of negative 5. It's the negatives again. So watch what happens. F of negative 5 is 26. That minus is part of the what we're told to do. And then the negative 9 has a negative, right? So the minus and the negative become plus plus. So that ends up being 35. Did you catch that? All right, f minus g of x, that's f of x minus g of x. So we're going to use parentheses. This is a great habit to get into. F squared plus 1 minus parentheses x minus 4. There's nothing to distribute in front of this one, but there is something to distribute here. We have to distribute the negative to both, so that's x squared plus 1 minus x plus 4. Did you get that? Add like terms and you get x squared minus x plus 5. Is that it? Yes, all we did was created a new function. So we end up seeing that if we add a parabola function to a line function, you're going to get another parabola function. And I don't really know where that graph is. All I know is the y-intercept is like 5, probably something like that. Okay, number 4. What happens when you add a parabola and another parabola? What happens when you subtract a parabola and another parabola? You might want to pause the video and just try all this and see if you get it. So the domain of f minus g, well, the domain of f is all real numbers. The domain of g is all real numbers. So the intersection domain is negative infinity to infinity. Find f plus g of 4.5. I would use my calculator, definitely, and find f of 4.5 and g of 4.5. And I'm going to use parentheses. So f is parentheses, clear that, parentheses 4.5 quantity squared, and then minus 1. And 19.25. That's a terminating decimal, so I'm going to leave it a decimal. I'm not approximating it because it terminated. That's exactly the answer. And then G, oh, here's an interesting thing. This negative x squared really means negative 1 times x squared plus 4. So it's important to put the parentheses correctly. So this is negative 1, you might even put in there, times 4.5 squared plus 4. Or if you just put in negative parentheses 4.5 squared plus 4, you get the same thing. Okay, but if you write it out, you might make a mistake. So if you write this out like negative parentheses 4.5 squared, use parentheses every time, you might think that you're supposed to distribute the negative in first before you square. Well, no, no, no. PEMDAS says you have to take care of exponents before you multiply. So you got to square that 4.5 and then make it negative. But your calculator does it if you enter it correctly, so that's negative 16.25. All right, then we're supposed to add the two values together. So 19.25 plus a negative 16.25 is 3. F plus g of x means you're creating a new function. So that means you're going to add f of x, which is x squared minus 1, and g of x, which is negative x squared plus 4. And then you're going to add your like terms. So x squared and negative x squared are like terms. They add to 0. So this function is just 3. So this parabola upside down and this parabola up down add up to be just the line y equals 3. So this is the notation without function notation. That's the line y equals 3, which makes sense that that was 3. Any number you put in, you can try it out, any number you put in for x is going to give you 3. All right, the domain of f minus g is all real numbers because there's no constraints on the f and there's no constraints on the g. All right, so we have some fractions. I'm going to write this out. So f minus g of 3/7. Again, I would not subtract the functions first. I would find f of 3/7 and find g of 3/7 and then subtract them. So I'm going to show you fractions. It's scary for people, but with your calculator it shouldn't be. This is my input, and I'm going to square it. I'm going to use parentheses, see that? Minus 1. And I'm going to use my calculator. But if you did not have a calculator, the algebra rules are this square goes to the numerator and the denominator. So 3/7 squared is 9 over 49, just so you know. And 9 over 49 minus 1. So I'm going to put it in, though, without, you don't have to know arithmetic. Your calculator will do the arithmetic. You just have to know the algebra. And that's going to give me a really nasty decimal, I think. And so this is what the decimal would be, and if you hit the squiggle, it will turn it back into a nice fraction, negative 40 over 49. So now you know where the 49 came from because 7 squared was 49. G of 3/7, I'm going to put the function, the number in, negative 3/7 with parentheses around the 3/7 squared plus 4. Let me use my calculator. And remember what it's going to do is it's going to square the 3/7 first, which gives you 9 over 49, and then take the opposite, which is negative 9 over 49, and then add 4, and you're going to get 187 over 49. And then what you're supposed to do, you're supposed to subtract. So negative 40 over 49 is f of 3/7 minus, and then positive 187 over 49. So I'm going to use my calculator. Negative 40 over 49 minus 187 over 49. And if it gives me that nasty decimal, I don't want that. I don't want you to approximate. You got to give me the exact answer. So hit the squiggle. That's negative 227 over 49. All right. F minus g of x means create a new function by subtracting the two functions. Use parentheses. That's x squared minus 1 minus parentheses negative x squared plus 4. Before we do any subtraction, I'm going to distribute the negative. That's the most common error in Math 171. So that's x squared minus 1. No parentheses needed because nothing got distributed. Here I'm going to distribute the negative. That's going to become a positive x squared. And that becomes a negative 4. So 1x squared plus 1x squared is 2x squared. And minus 1 and minus 4 becomes minus 5, and so that's our new function. And if I were to graph that so you could see it, I don't have much time, but it's going to go off the page. It's going to have a y-intercept of negative 5 and be a little bit more of a vertical stretch, so it would look like something like that. That's what f minus g of x would look like.